Welcome back to Mathland. This is lesson 10 of Algebra 2 Remote Learning with Hotard. Last week we were multiplying and dividing rational expressions. Today we're going to be adding and subtracting rational expressions. It's such an exciting lesson, you might just wet your pants. So have a change of underwear on standby, and we're going to get started with the math. Okay, this is going to be a two-part lesson on adding and subtracting rational expressions. Remember, rational expressions are just fractions that have variables in them. All right, so we're just going to quickly, before we start in the algebra, we're just going to review adding and subtracting fractions. So 1/5 plus 2/5, that is not 3/10. All right, if you think about it, if you have a pizza cut into 5 pieces, you eat one of the 5 pieces, and then you come back and eat 2 more of the 5 pieces, you haven't eaten 3 out of 10 pieces. You've eaten 3 of the 5 pieces, 3/5. Adding and subtracting fractions, you could just work out the top after you have what? A common denominator. You have to have a common denominator to work out adding and subtracting fractions. So if you don't have a common denominator, like in this problem, you have to get one. So 1/5 plus 2/3, I want to know common denominator of 5 and 3. All right, I'm looking for the least common multiple. Just think about if you count by 5s, 5, 10, 15, 20, you count by 3s, 3, 6, 9, 12, 15. The first number to show up in both lists is going to be 15. So I'm going to change both of these into common denominator of 15. All right, and remind me again, what do you do with 5 to get 15? 5 times what? Times 3. So whatever I do to the bottom, I do to the top. So I multiply 1 times 3, turn that into 3/15. Now 2/3, what do you do to 3 to get 15? 3 times 5. So I'm going to multiply the top times 5. 2 times 5, going to give me 10/15. And now common denominator, I can just add those fractions. 3/15 plus 10/15, going to give me 13/15. All right, one more. 3/4 minus 3/8 subtraction, work it just like addition. I need common denominator. Now, a lot of times people want to multiply these together. You don't have to do that. All right, if you count by 4s, 4, 8, 12. You count by 8s, 8, 16, 24. LCD, first number to show up in both those lists is just 8. All right, so 4 times what gives you 8? 2. So multiply the top times 2. 3 times 2 can be 6. All right, second fraction already has an 8. I don't have to do anything to it. So it's just 3/8. 6/8 minus 3/8, the answer is going to be 3/8. So that's adding and subtracting fractions. You just need to find your common denominator if you don't already have it, and then do whatever you did to the bottom to get that common denominator, do it to the top, and then work out the numerators. Okay, so now let's apply that to algebra, to these rational expressions. Now, first set of problems we're going to do algebraically, they're already going to have common denominators. So these are going to be easy. They look hard, but they're actually easy because if they have the same denominator, I'm just adding the top or subtracting the top. 3x plus 9x. I'm going to combine like terms. So 3x plus 9x is going to give me 12x. 8 plus negative 11. So 8 minus 11 is going to be negative 3 all over the denominator was 5x. That's the answer. Not hard. So second problem, I have common denominator already, 16n squared m. So I'm just working out the top, combining like terms. They have to have the same variables to be like terms. So m plus 6m is going to give me 7m. And then I have negative 2n. I have positive 2. Oh, that's I didn't even catch that. That's a plus 2m. So I'm going to combine that with the plus 7m. So tricky. That's going to be 9m, and then you just have that minus 2n. Nothing you can combine with that. All over 16n squared m. That would be my answer. All right, one more of these. Last example with the same denominator. This is a subtraction problem, so just be careful. All right, the answer to this one is not going to be 5x minus 9. All right, because that minus goes to the 7x and the 10. You're subtracting 7x and you're adding 10. You're distributing that minus. So 12x minus 7x is going to give you 5x. And then 1 minus negative 10. So 1 plus 10 is going to be plus 11 over x minus 2. Now, before we get into the unlike denominator problems, I want you to pull up the practice problems I put on Moodle for this. All right. I want you to look at problems number 10 through 18. Those already have common denominators. But I do want to point something out on these. So really quick, a few of these problems, like for example, number 13. If you look at number 13 on the practice problems on Moodle. All right, yes, they have the same denominator, so you can just work out the top. 5x minus 4x going to give you x. 1 minus -7, so 1 plus 7 will give me 8. So a lot of people think, okay, the answer is x plus 8 over x squared minus 64. But you can simplify this. I can factor the bottom. Remember, we did simplifying these last week. X squared minus 64, factor it. What numbers multiply to give you -64 and add to give you 0 for your middle term? Plus 8 and minus 8. So I can factor that bottom into x plus 8, x minus 8. And then I can cancel out the x plus 8. So my final answer there is going to be 1 over x minus 8. All right, that does happen on several of these problems. Just look to see if the bottom, if you could factor it, all right, then try to cancel something out. Sometimes you can't. Sometimes it can't be factored. Sometimes you could factor it, but nothing cancels. But if it can cancel, and there's a lot of them in the practice that do that. If you could factor the bottom and something cancels, do that. Reduce it. All right, so try those problems and then come back and we will finish the video. Okay, so let's look at our last set of problems for today. Now we're going to look at what happens if we don't have the same denominator. Now, we're only going to get into part of this today. We're just going to look at what's called monomial denominators. Remember, a monomial has just one term. There's no plus or minus in the denominator. We'll get into the more complicated denominators next time. So if I don't have common denominator, just like I did on these problems up at the top, all right, just like regular fractions, I need to get the same denominator. So to find your common denominator, and the hardest part of this lesson right here is just figuring out in each problem, what is my LCD? What is my common denominator? Right here, this example, this one has a 2x squared. This one just has a 2. All right, so my LCD, if anything shows up in the denominator, it needs to be in the LCD. They both have a 2. This one also has an x squared. So the LCD is going to be 2x squared. So I'm going to change both of these into something over 2x squared. Now, first fraction already has everything I need. So I don't have to change anything. Leave that as a 3. But the second fraction, it has the 2. What did it not have? X squared. So I have to multiply top and bottom by x squared. So that's going to give me 6x squared on top. So now I have my same denominator, so let's put it together. Now they're not like terms on top, so don't try to subtract them. It's just going to be 3 minus 6x squared all over 2x squared. Now, when I teach this lesson, sometimes people ask me, wait, can you just cancel out x squared? No. Remember, you can only cancel out if you can divide it out of the entire top. Like if the whole problem had an x squared, or if everything on top could be divided by 2, then yes, you'd simplify. But that's it. All right, a few more. Look at the next example. I need my common denominator. I have 6x to the third and I have a 3. So my LCD this time, let's just start with the numbers. 6 and 3. If you're looking for least common multiple, count by 6s. 6, 12, 18. Count by 3. 3, 6, 9, 12. What's the first number to show up in both lists? Is 6. All right. And then this one also has an x to the third in it. So I have to include that in my LCD. 6x to the third. All right, so that's my LCD. I need to change both of these fractions into something over 6x to the third. So first fraction already has everything I need. Leave that as a plus b. Second fraction. First of all, the number. I have a 3. I need to get to 6. So 3 times what? Times 2. And then what else is missing? The x to the third. So I'm going to have to multiply top and bottom by 2x to the third. So 2 times 2x to the third is going to become 4x to the third. Again, you're multiplying whatever is missing from that fraction to get to that LCD. Now, I have my common denominator, just combine like terms. There are no like terms on top, so just put it all together. A plus b plus 4x to the third, get that on the screen, plus 4x to the third, all over 6x to the third. That is my answer. Okay, 2 more quick problems. We are almost done. All right, this time I have 2x to the third and 4x squared, my LCD. Let's start with the coefficients. 2 and 4. What's the least common multiple of 2 and 4? It's 4. 2, 4, 6, 8. 4, 8, 12. 4 is the first number to show up in both lists. Now, this one has 3 x's. This one has 2. All right, anything that shows up in the problem has to be in your LCD. So that means my LCD is going to be 4x to the third. Basically, it's going to be whatever the biggest exponent is for these monomial problems. All right, 4x to the third. So I need to change both of these fractions into something over 4x to the third. So the first fraction has the x to the third. I just need to multiply by what to get 4x to the third? By 2. So I'm going to multiply top and bottom times 2. So that's going to give me 6x times 2 going to be 12x. 12x on top. And then second fraction, I have 4x squared. I need to get 4x to the third. So what do I need to multiply to get 4x to the third? I need to multiply times x. X squared times x will give you x to the third. So top and bottom times x. So on top I'm going to get 6x. So now let's work this out. 12x minus 6x, that one I can work out. That's going to give me 6x over 4x to the third. Now that is correct, but it is not finished. I can reduce this. First of all, 6/4, I can divide those by 2. Going to give me 3 over 2. And then the x's, remember that's x to the 1. What do you do with the exponents again when you divide? You subtract them. Going to give you x squared on bottom because that's where the bigger exponent was. So my answer is going to be 3 over 2x squared. Last one. All right, last monomial problem. 5x squared and 2y to the third. I need my LCD, my least common denominator. All right, first of all, for 5 and 2, count by 5s, count by 2s, LCD is going to be 10. All right, this one has an x squared, this one has a y to the third. I need to use them both. Anything that shows up in the denominator has to be in your LCD. So 10x squared y to the third is going to be my whole common denominator. So let's change both of these into something over 10x squared y to the third. All right, so first fraction, I have a 5, I need a 10, so that means I need to multiply by 2. I have the x squared, I don't have y to the third, so I'll multiply by 2y to the third. 2y to the third on top and bottom. So that on top, 3 times 2y to the third is going to give me 6y to the third. Now, sometimes when I teach this, people are like, wait, shouldn't I reduce this? If you reduce it, it's going to bring you right back where you started. Don't reduce it yet. Work it out first. All right, and then second fraction, 2y to the third, I need 10x squared y to the third. So I have the y to the third. 2 times what will give me 10? Times 5. And then what else is missing? X squared. So 5x squared. Multiply top and bottom by 5x squared. So 3x times 5x squared going to give me 15x to the what? To the third. X times x squared. It's x to the third. So now, got my common denominators. Let's put them together. That's going to be equal to, they are not like terms. All right, that's got a y, that's an x, so leave them separate. That's going to be 6y to the third plus 15x to the third all over 10x squared y to the third. All right, no, you cannot reduce that. I can't reduce all the numbers by the same number, and they don't all have an x, they don't all have a y. So that is my final answer. Okay, so I want y'all to go ahead and try the rest of the practice problems. In a day or two, I'll be posting a new lesson on still adding and subtracting, but with denominators that are not all monomials. If you have something plus something or something minus something in the bottom. It'll be a lot of fun. I know you're excited about that, but you're going to have to wait. I'm sorry. But y'all have a great day. I'll catch you later.